Now we can see the realization of IIR filters. While we are realizing the IIR filters, the filters can be realized by using direct form 1, direct form 2, cascade form and parallel form. This is the block diagram representation of the elements. If it is an adder, it is represented like this by using the block diagram representation. If it's a constant multiplier, we are representing this by using small triangle, and by using the unit delay element is represented by using x of k into z bar minus 1. Now first direct from 1 realization. Here for direct from 1 realization, where in the case of transfer function we are just taking the z transform, we are multiplying and we are taking the z transform on both sides, and finally we are realizing. While we are realizing in the direct form realization, the summer comes in the middle part and the delay elements comes in both sides. And the disadvantages of direct form 1, this structure uses the separate delay for input and output samples, so more memory is required, and the choice of realization of the system is influenced by the following factor. That is, we can reduce the computational complexity, memory requirements, and the finite word length effects in computation, and we can choose the parallel processing or parallel pipelining. We can see one problem. Let us consider the block diagram of the system whose input-output relations are described by the difference equation y of n equals 0.5 x of n plus 0.5 into x of n minus 1. Here we want to convert this in terms of h of z. Therefore, we are finding the z transform for this equation. After finding the z transform, we are finding the value for h of z. Therefore, h of z equal to y of z by x of z. And here we are only having the denominator term. Therefore, we are just realizing this like this. This is the block diagram representation. And next term, here also they are asked to find the difference equation by using direct form 1. That is, y of n is given. Now we want to take z transform on both sides of this equation, and we are finding the value for h of z. Therefore, h of z equal to, we want to find the value for h of z. Therefore, by using the h of z, in this we are having both numerator and denominator. Therefore, we are just realizing this numerator and denominator, and also in the case of numerator and denominator, we are having the terms in terms of z bar minus 1. Therefore, we are just realizing by using the block diagram representation. This is the generalized block diagram of a direct form 2. That is the only difference between the direct form 1 and direct form 2 is, here the case of direct form 2, some delay element comes in the middle part and the summers goes in the two side. But in the case of direct form 1, the summers comes in the middle part and the delay element goes on both sides. Okay, that's the only difference. No other changes there. Now direct form 2, here also we are taking the z transform and we are finding the value for y of z. And while we are finding, here we are just introducing an intermediate term. Therefore, w of z, y of z by x of z, we are considering that as the numerator value, and w of z by x of z, we are considering this as the denominator value. Now this is the direct form 2 structure. While we are going to find the direct form 2 structure, here also for the given system function, we are just realizing this by using the direct form 2 structures. While before realizing, here they are given the sequence in terms, given the system function in terms of time domain. Therefore, we want to convert this in terms of frequency domain. Therefore, we are just taking the z transform on both sides and finding the value for h of z. After finding the value, we are just realizing by using the direct form 2 method. Our next one is cascade form. In the cascade form, the cascade form is realized. Here we are just dividing the blocks into smaller subdivisions, and also here the transfer function is divided in such a way that the order of the numerator must be less than or equal to the order of the denominator, and also each block's h1 of z is realized by using the direct form 2 method, and finally we are connecting all the direct form 2's. Here this is the generalized structure of the cascade form. Now while we are doing the problem, here they are given the difference equation. Here also we want to take the z transform and we are splitting this into two equation. After splitting this equation into h1 of z and h2 of z, here we are just connecting, that is h1 of z and h2. In the case of h1 of z, we are having both numerator and denominator, and in the case of h2 only we are having the denominator. Therefore, we are realizing once. Okay. Now here in this is split in such a way that the numerator must be less than or equal to the denominator. Parallel form, here the parallel form, We are performing this by using the partial fraction expansion method. And also here we want to keep one thing in mind, the numerator must be always less than the order of the numerator must be always less than the order of the denominator term. This is the parallel structure, and again each system function is realized by using direct form 2 method. And we can see the problems. This is a given system function y of n. Here same as in the previous case, we want to take this transform on both sides, and finally we are finding the value for h of z. After finding the value for h of z, we are going to apply the partial fraction expansion. After finding all the values for a, b and c, we are substituting the values, and finally we want to connect this in the system function. Here it is connected in such a way that one below the other. We want to connect the system function. Realize this by using the direct form 2 method, and we want to connect in such a way that one below the another, therefore it forms the parallel realization. That's all.